All right, this is video number 2 of lesson 7.3 as we're talking about similar triangles. So we are going to finish up this lesson with the back page. Similar parts of triangles. So we are given that two sides are parallel. We're given some side lengths and we need to find RQ and QT. Well, it might be super easy to just set up a proportion, but before we know sides are proportional, we have to know that my triangles are similar. So we need to figure that out first. Because I have two sides that are parallel, I also know that I have angles that are congruent. So angle U is congruent to angle S. And I also know with those parallel lines, angle T is congruent to angle R. And we learned in the first video that if I have two angles that are congruent, I then know that my triangles are similar. With my triangles similar, I then know that my sides are proportional. So this is why I can now set up a proportion to start solving for x and then plugging it back in. So I'm going to start my proportion out 10 over 4. Starting out with sides that have the same value. So I'm going to go big triangle over small triangle equals big triangle 2x plus 10 over small triangle x plus 3. Make sure that you're staying consistent with your proportion. So I'm going to cross multiply 10x plus 30. Remember to distribute because that goes together. Equals 8x plus 40, again going together, moving with each other. I'm going to subtract 8x from both sides, so I get 2x plus 30 equals 40, subtracting 30 from both sides. 2x equals 10, so x equals 5. So again, I need to find my big side QT, so I need to plug it in over here. So 5 times 2 is 10 plus 10 is 20, and then I'm going to plug it in over here. QR equals 5 plus 3 is 8. So I can check myself if I do that because I know sides are proportional. I know that 20 over 8 must equal what I started with, 10 over 4. If I reduce those down, they are proportional, so that does work out. All right, go ahead and stop your video to try your next checkpoint. There is your answer, D. And last example, one of my favorites, if you've ever heard of the shadow project, or the shadow example. So Josh wanted to measure the height of the Sears Tower in Chicago, something that would be very difficult to measure. He uses a 12-foot light pole and measures its shadow at 1 p.m. So I have the sun out, and I have a light pole that is 12 feet high, and its shadow at 1 p.m. is going to be 2 feet. Alright, so I'm going to finish up that triangle. So that's one part of the problem that we have. Then he measures the length of the Sears Tower. So I have the Sears Tower over here. I measure the length of that shadow, and that is 242 feet. What is the height of the Sears Tower? So I'm going to put that as x, the height as x. So notice when you are doing these shadow projects, because it's at the same time, that allows you to say that that sun is creating an angle with the ground for both parts. So that angle is congruent, and of course I have a right angle So that means that those two triangles are similar by the AA similarity postulate, which then means my sides are proportional. With the sides proportional, now I can set up a proportion, and you might do it a little differently. I'm going to go my height over my shadow equals, and I need to stay consistent, my height over my shadow. And you might say height over your height equals shadow over your shadow, however you want to do it. So I'm going to go my light pole first, height over my shadow equals, and then I'm going to come over here, my height, which is x, what I'm trying to find, over my shadow, 242. To solve a proportion, I'm going to cross multiply. 2x equals 2,904. Divide both sides by 2. My height is 1,452 feet. So that would be a booger to have to measure with a yardstick or maybe something different. So you can use those shadows to help you with similar triangles. So you have one more example. Go ahead and stop this video. Try your next checkpoint. Here is the height of the lighthouse to the nearest foot. And a couple things to review before we move on. 3 ways to prove triangles similar. We have AA, SSS, or SAS, and remember what they mean. And then if 2 triangles are similar, so if I use problem number 1, if 2 triangles are similar, I also know 2 things. 1, all my angles will be congruent, and my sides will be proportional. And that wraps up 7.3.